So I'm Niraj Dengale from Andy's Technology. I'm going to present a topic before you, which is unlocking RISC-V's potential in intelligence application processing. I'll talk about RISC-V adoptions in some large-scale SoCs, some SoC examples with application processors, some AI-able application, and more details about application processors. To go through our lineup quickly, this is our all RISC-V processors based on RISC-V, all provided by our Andy. We call it Andy scores. They cover wide range of categories in applications, starting from embedded applications like two-stage single issue, three-stage single issue pipeline cores like Ender-Dufay, T23, then 25 series, which is five-stage single issue, then going up to 27 series, which is also five-stage single issue, but addition of MemBoost functionality, which is giving you more better memory bandwidth and performance. Up from 27 series is 40 series, which is the 45 series cores. All our cores are dual issue, 8-stage CPU in order. And the latest from our offerings is the 60 series, which is out of order 30-stage quad core issues. On the right-hand side, you see FUSA cores, which are SLB or SLD certified, depending on which core you are considering. So we have D23 SE, which is three-stage single issue, D45 SE, which is eight-stage dual issue, and also upcoming cores like already like going for mass production, N25 SE and D25 SE cores. So we cover all the areas from M0 level from ARM up to A76. We cover all this corresponding RISC-V similar performance compared to ARM. The SSD group has done a study and they have verified that Andes has over 30% of the RISC-V IP market. So we have different customers which are in different applications like mobile, MPU, AIoT, storage, 5G networks, space, as well as large-scale AI and machine learning. I will go through some of them in the upcoming slides. Okay, so the renowned recent application of Andes processors is MTR chip from Meta. So they have published the paper of their first generation silicon. It's based on the NX27V, the first vector core from RISC-V, which was commercially available and contributed by Andes, and also adding our custom extensions. So it is custom extension are allowing you to add your own custom instruction on top of the standard RISC-V instruction set. So this is the first generation of Meta, and then they went for the second generation as well with Andiscore, which is 3 times the improved performance, and also they achieved the 6 times model serving throughput with the second generation and with a newer vector core from Andes. In large-scale AI and machine learning, we have customers which are doing application based on NX27V, X45 MPV, as well as X65, which was the out-of-order CPU core. And they have also integrated the Andes custom extension to further enhance the performance and better usage. For examples like AI accelerators using SRAM in-compute memory, we have customers like Accelera, Homo, REN, and TetraMem. For AI accelerator using photonics, light intelligence. Also, we have customers for AI accelerator for ADAS, as well as AI accelerator for cloud service, a Korean company called Sapien. Then Andiscore in large-scale SoCs, we have multiple applications. We have customers which are using Andiscores as processing elements for AI and machine learning and ADAS. We have use cases which are using channel processors for storage, 5G and networking. And we have customers which also use peripheral processors in media-rich computing platforms like phone, TVs, and tablets. In those kind of scenarios, the cores will be based on, will be used in applications such as Wi-Fi, Bluetooth, touch, storage, and security. And RISC-V's ecosystem is also growing, and we have many control processors which is matured in RISC-V, and we have communities which is supporting GNU, LLVM, Linux, as well as Android development. So it's time to advance RISC-V to enter the center of application processing. And I will go through some Andy solutions best focused on AI and machine learning. So we call it Andy's Air, which is stands for Andy's AI running everywhere. We have hardware as well as software solutions for AI from endpoint to the cloud. On the left-hand side, you can see if customers require some Linux processors, application processors, we have x65, x45MP, as well as x25MP. If they want to do compute acceleration, then we have vector processors, the 27V and 45 MPV. And if it comes to hardware accelerator like NPU, if they require, which are already working with our cores, then that would be ANDLA i350. We can also do LLVM with auto vectorization support. And we have what we call Andy's Air NN Pilot. So NN Pilot helps in pruning, quantization, optimization, and as well as evaluation. So it can have two different generation from Andes Air. It can NN Pilot. It can be either directly generated C code template, which can you provide you to LLVM with auto vectorization and further run it on the hardware core, or you can generate NN models, which you further provide to NN inference engines like TensorFlow, TensorFlow Lite, TVM, and then run it on the Andes core. You can further improve the performance by using Andy's custom extension by writing your instructions to get better performance. There is vector processor families from Andy's, the 27V and 45 MPV, which have been used by Meta, I talked about earlier. So they have vector length from 128-bit to 512-bit for NX27V. For 45 MPV, the vector length can go to 1024, and then for 46 MPV and 47 MPV, it can go to 2048 bit. So the 46 MPV and 47 MPV, which are upcoming, they will also have integrated matrix extension and 16-core cluster, where the 45 MPV, which is already market and already mass production, has 8-core cluster. Then Andy's automated custom extension, the ACE that I was talking about, it is letting customers to create their new instructions to speed up the computation and controls. So the ACE can let you add your own instruction to the existing RISC-V ISA. The Copilot tool that we provide, it is going to you only need to write the Verilog for the new instruction, the concise Verilog. You have to write the C behavioral model and the ACE file. ACE file is just input-output operands for that instruction. Once you provide these three files as input to the Copilot, it is going to generate the extended RTL. It's going to generate the extended instruction set simulator and other tools to let the compiler and the debugger know that this is the new instruction added along with the existing RTL. So you can then run the profiling again and see how much performance difference that you received after adding this new custom instruction. For VPU, we also have RVV. So you can also directly communicate with the vector processing unit for better adding better custom extension. So for application processor, we have 60 series core, which is x65 already in the market and licensed by various customers. It is 30-stage 4-way 64-bit out-of-order processor. It has multi-core cluster up to 8 cores, and it is also Linux capable running. Has level 2 caches, 2-level caches, private instruction and data cache, and also shared caches. And for the bus interface, it has the 256-bit XE4 for memory, MMIO, and IO coherence ports. For performance, it's 2.6 gigahertz at 5 nanometer TSMC, and spec-int is 8.25 per gigahertz, and for float integer and for floating point, it's 10.2. If you compare with the CA75 or 76 at 7 nanometer, you can see the huge performance per area advantage over these two ARM cores. This is for reaching the same performance, they had to add the L2 cache, but without that, we have already reached the spec-int and that kind of performance. For our roadmap, we have x65 already available in the market. We are coming up with the X66, which will comply with RVA23 and vector crypto extension let it run Android, and also AX67 in the upcoming roadmap, which will also support RVA24. So this also support hypervisor extension, AIA, as well as IOMMU and IOPMP. There is X63 planned as well for more power optimized and power concerned customers. So for software ecosystem, we have rich software ecosystem around Andy's course. It's based on Linux. If you can talk about Linux, we have Linux RISC-V support in different distributions like Yocto, Debian, Fedora, OpenWRT, and OpenSUSE, and also development tools and library for both GCC and LLVM. We are part of the RISE, the RISC-V software ecosystem, along with some huge names, and we have also contributed various things from our side for this RISE ecosystem, like compiler, QEMU, and OPT for the trusted applications. And Android is coming to RISC-V. We are already ready for that, and we have already supported Linux version and toolchain used in Android by Andis, and also working on upstreaming the Android source code on QEMU, and also system bring up like AV playback and built-in apps, etc. Also optimizations such as RVV for libjpeg turbo. So our approach to RISC-V is simple. We are establishing market confidence on RISC-V architecture. As mentioned, we cover our 30% of the RISC-V market, IP market globally, and we are growing this ecosystem to strengthen the application support and also developing innovative projects like the 60 series, which is also be able to run AI and also Android on top of it. And our achievements include deeply embedded protocol control, the general purpose MCUs as well as MPUs, and compute acceleration. The next step for our application processors is X46 MPV, which is coming, and 47, as well as 66 and 67, which is the out of order course, and Cusco as well. That's it from my presentation. Thanks a lot for joining.